Alright, guys, welcome back to my YouTube channel where we have a playlist of solving the AQA 2025 chemistry past paper question. I won't be solving all the questions, but questions that we have access to, we'll be solving them together to ensure that you do well in the exam and you have the highest grade possible in chemistry. So we'll move to question 2. The question is determine the empirical formula of calcium sulfate. First, one of the things we need to understand is that we need to know what an empirical formula is. So, what is empirical formula? Empirical formula is the simplest formula of a compound that shows the ratio of how an element reacts with one another. We have three formulas in chemistry, which I need to explain very fast. We have empirical formula. Empirical formula is what I just explained. It shows the ratio of how an element reacts with one another. We have molecular formula. The next one is molecular formula. Molecular formula shows the actual number of atoms, shows the actual number of atoms. Then we have structural formula. From the word structural formula, structural formula shows shows the arrangement. So empirical simplest formula, molecular shows the actual number of atoms, while the structural formula shows the arrangement of atoms. These are the three formulas you will be exposed to in chemistry. The concept of empirical, molecular, and structural formula. Now let me explain that concept in details for people that might not really understand what we just said. If we have glucose, for example, the formula for glucose is 66H12O6. The actual formula of this is what we call molecular formula, MF. What's the simplest formula in 6H12O6? All are divisible by 6. Let me divide all through by 6. So I have CH2O. This is the simplest I can get from this. So this is empirical formula. And what structural formula? Structural formula is when we decide to draw the structure of glucose. I quickly do another example so that we understand again. Water, for example, what's water? Water is, okay, don't let me use water as an example. Let's use calcium sulfide. What's the actual formula of calcium sulfide? The actual formula of calcium sulfide is CAS. So CS is the molecular formula, calcium sulfide. Because it cannot be divisible again, we can't divide it further. So CAS is also the empirical formula. While the structural formula can just be Ca and is attached to a bond of S. So structural has to do with their structures. So the empirical formula of calcium sulfide is CS. Hope you got that. So you can try this and let's see in your spare time that you have, you can try this together for water. What is the empirical, the molecular, and structural formula for water? You can also try this, which I'm going to do the correction for the second one. If you have for ethanol, C2H6. No, let's do for ethane, C2H6. And let's do the correction together. For ethane, this is the molecular formula. So the empirical formula will be divisible by 2. So it is CH3. So this is the empirical formula. Why the structural formula is C2, then H, 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 and H. Hope you got that. Then we'll move to the second one very fast. Describe the structure and bonding of graphite. Describe the structure and bonding of graphite. It's very simple. And the answer is graphite is made up of layers of carbon atoms covalently bonded in hexagonal shape. One of the first features of graphite is the hexagonal shape. We have two forms of carbon, which is diamond, for your level is diamond and graphite. Why are they the major structure of carbon? Is because they have a known shape. The shape of diamond is octahedral, while the shape of graphite is hexagonal. Alright? So there are no covalent bond between the layers, so they can slide over each other. And they form three covalent bonds to others, so it has free delocalized electron. This free delocalized electron, it is what is responsible for graphite being a conductor, being a conductor of electricity. Anytime you want to know a substance that conducts electricity in chemistry, it is the ability to have free delocalized electron. The next one, explain why polyethylene has a higher melting point than methane. Methane consists of small molecules. Polyethylene is a polymer. Anytime we talk about high melting points in chemistry, I need to be giving you this shortcut. This channel is to understand chemistry and you can apply it in different phase or in different questions. That is why you need to tell your friends to please subscribe to this channel, SG Academy. Click on the notification bell, like, and drop a comment so that we can improve in doing our next video and improve all over and over again. Anytime you see a question that is stipulated, why is a substance having a higher melting point or boiling point than the other? It is because they have strong intermolecular force of attraction. And the simple answer to this is that polyethylene has a stronger intermolecular force of attraction than methane. It's as simple as that. Having a strong intermolecular force gives you your answer immediately. Again, explain why polyethylene has a higher melting point than methane. Same principle again. The concept of higher melting and boiling point is the same thing. It's because they have a stronger intermolecular force of attraction. Thank you so much. This is the question 2. Please stay glued to this channel, subscribe, and join us as we continue in solving the AQA past paper question for 2025. Thank you. See you in the next one.